Hi, I am Dr. Chanbat Tirupati, Head of the Department of Civil Engineering, Session Institute of Technology and Engineering. So welcome to the Fluid Mechanics next class. So in this class, actually previous classes we have discussed about the fluid properties. So we have discussed all the fluid properties including surface tension and capillary action, and we have solved some numerical problems in the previous class. So in this class we will talk about fluid pressure and its measurement. So that means what is fluid pressure? So how to measure the fluid pressure at using different instruments, so that we will discuss, right? Okay. Now what is fluid pressure? Yeah. So what is fluid pressure? The fluid pressure is nothing but the pressure exerted by the fluid, right? The pressure exerted by the fluid. For example, so if you, the water is flowing in a open channel, right? This is one, you can say a canal. So the water is flowing in the canal, right? There is some rock is present in the bottom of the canal, right? The fluid, whatever the fluid passing through this canal exerts some pressure on this solid body present in the fluid. So that you can call as a fluid pressure. So fluid pressure is the pressure exerted by the fluid, which is known as the fluid pressure, right? So if you carefully observe here, I think I'll write in a better way. Yeah. This is the free surface of the fluid. So the fluid is flowing. Okay. So there is a solid body present in the fluid. So if you see this point, for example, if you consider this point, okay, if you consider this point, so what are the fluid particle present in this point will exert pressure on this solid body, right? Exert pressure on the solid body. So if dF is the force acting on the solid body per this unit area where it is acting, so that you can call as a pressure intensity, right? Pressure is force per unit area, that is dF by dA. If dA is a small area of the solid body and dF is a small force acting on the small elemental area, this is P, pressure intensity. If you want total pressure acting on the body, so if you integrate you will get that is P is equal to F by A. So pressure is force per unit area, how much force is acting on the solid body per unit area, right? Okay. Now one of the important term we will discuss here, it is hydrostatic pressure. So what is hydro? Hydro means water, static means at rest. So when the water at equilibrium condition, the pressure exerted by the fluid, that means water. So is the pressure exerted by the fluid at equilibrium condition at a given point within the fluid. This is because of force due to gravity, gravitational force. So hydrostatic pressure is the pressure exerted by the fluid when it is equilibrium condition or at rest condition. So we will discuss in detail about hydrostatic pressure, how to find out the hydrostatic pressure at various points in the coming slides. So I hope you understand the definition of the fluid pressure. Fluid pressure is very simple. So fluid pressure is the pressure exerted by the fluid. For example, this is very important. For example, if you want to design a dam. So for example, we want to design a dam. So what we need to understand? I will tell you, yeah. So there is a dam, you want to construct a dam here, right? There is a canal is passing, or this is a river. So you want to construct a dam across the river, right? What will happen if you construct the dam? The water will stand, right? So we will block the water here. So the water will stand, so the standing water will exert pressure on the walls of the dam. That we need to find out. So the pressure at equilibrium condition. For example, in your home, if you have an aquarium, small aquarium, what will happen? So whatever the fluid inside the container will exert pressure on the walls, right? That is a simple example for static pressure. Or if you kept water in your pot, if you kept some water in the pot, so the fluid inside the water will exert pressure on the walls of the pot. So that is at rest condition. The fluid is not flowing, right? It's not flowing, it is at rest condition. The fluid at rest condition will exert pressure. That you can call as a hydrostatic pressure. That we will discuss. How to measure and how to calculate. So next we will talk about hydrostatic law. So what a hydrostatic law will state? So hydrostatic law will state that the intensity of the pressure intensity or rate of increase of pressure is in vertical direction. So for example, if you see, I have considered this is a container, right? So I have a liquid up to here. So it is filled with some liquid, I can say water. It is filled with some liquid, I can say water. So the pressure here, it will be different from the pressure here and here and here and here, right? So hydrostatic law will state the rate of pressure, the pressure intensity or rate of pressure in vertical direction. So will be equal to the specific weight of the fluid. It depends upon the specific weight of the fluid. So what is the specific weight? We already derived the expression for specific weight in the previous topics. So specific weight is weight by volume, right? How much weight the fluid, you can say fluid contains per unit volume. So for example, if you say 1 cubic meter of water, how much weight it contains, that is the specific weight. So the rate of pressure or the increase of pressure will depends upon the specific weight of the fluid at that particular point. For example, if I want to measure the pressure here, it is depends upon the how much specific weight we have at this point. At this point. So which is expressed in the pressure here, it will be expressed in pressure means force per unit area, that we know, right? Force units are Newton and area is meter square. So that is Newton per meter square, which is nothing but Pascal. So when we use the term Pascal, which is represented with PA, so Pascal is nothing but Newton per meter square, right? We all know that the density, it is one of the important fluid property which we already discussed in the previous lectures. So density, we know that it is a mass by volume, right? So density is mass by volume. So mass will be equal to density into volume. So mass will be equal to density into volume. So what is the intensity of the pressure? Intensity of the pressure will be equal to specific weight. So what is the specific weight? Specific weight is weight by volume, right? So what is weight here? What is the relation between the weight and mass? We already derived earlier. So weight is equal to m into g, right? That means weight equal to rho g v, right? This is the weight. This is the weight, rho g v. Because m is rho v and g, if you substitute for example equation 1 in equation 2, you will get this one. So weight is equal to rho g v. So what is the specific weight here? Okay, this is the expression for weight, rho g v. Specific weight is weight by volume, that is rho g v by v. We cancel, it will be rho g, right? So specific weight is weight by volume, that is rho g v by v. V cancel. The specific weight is rho into g. So specific weight is nothing but density into acceleration due to gravity. This expression is also we have derived earlier. So that means The hydrostatic law, as per the hydrostatic law, the pressure intensity P is, or increase of rate of pressure in a vertical direction must be equal to specific weight. That means it is directly proportional to specific weight. P is directly proportional to specific weight. That is, P is directly proportional to rho G. Okay, I will yeah. If you see here, the pressure intensity at this point is 0. Why it is 0? So I have taken one container, right, which is filled with liquid. So at the free surface, here the pressure intensity is 0. Actually there is atmospheric pressure. So here the pressure intensity is 0. If you want to measure the pressure at this point, so it will be equal to rho G into H. So rho G is the weight into height. You will get rho G H. And here it will be rho G into H2. If you want to measure the pressure here, it is rho G into H3. Just wait. Yeah, we will discuss and again we will come back. Okay. Now, if you see here, this is the one container which is having a height of the container is H and area is A. That means what is the volume? Area into height, right? So what is the specific weight? We already derived specific weight is equal to rho into G, right? So what is the pressure? Pressure is weight by, pressure is force per unit area. Pressure is force per unit area. So what is the force? Force is nothing but weight. Weight per unit area. What we required? We required the pressure intensity. So what is the weight? Weight is rho G. Rho GV. This is the specific weight. So weight is equal to So weight is equal to M into G, right? So M is rho V G. So weight is equal to rho G V. Area is A. So what is the volume here? See, volume is area into height. So that means rho into G into area into height by area. So area will cancel. It is rho G H. So that means pressure intensity will be equal to rho G H. This is the expression used to derive the pressure at any point. Is it clear? Pressure means force per unit area. Force is nothing but weight per unit area. So weight is nothing but mass into acceleration due to gravity. That means mass is equal to density is equal to mass by volume. Mass is equal to density into volume. So it is rho Vg. If you substitute rho Vg here, weight is equal to rho Gv by area. Volume is nothing but area into height. So area will be cancelled. Finally we will get rho Gh. So the pressure intensity is nothing but rho Gh. Okay, now we will try to understand from here. So I want to measure the pressure here. So pressure at any point is, pressure intensity is rho Gh. So height of the liquid column is 0 at A. For this is the point, you can say A, and this is B, C, and this is D. So at A, height of the liquid column H at A will be 0. That means rho G into 0, it will be 0. So that's why here pressure is 0. If you want to measure pressure at B, the height is H1. So the pressure is rho G H1. And here it is rho G H2. This is at B and this is at C, and rho G H3 at, you can say, D. So the H1 value greater than H2, H2 value is greater than H1 and H3 value is greater than H1 and H2. So the height is increasing from top to bottom. That means the pressure will increase because the pressure is directly proportional to height of the liquid. The pressure is directly proportional to height of the liquid. If the height of the liquid is more, the pressure will be the more. That's why here the pressure is 0 and at the bottom the pressure is maximum, right? The pressure is maximum. If you join, you will get a triangle. So triangular force. This is about hydrostatic law. So what we sorry, what is the intake from here? The intake from the here is the pressure formula. You can measure pressure at any point by using this formula. P is equal to rho g h. So pressure is directly proportional to height of the liquid column. So the pressure, it is independent of the shape of the body and it is also independent of the area or any other parameters, right? So it only depends upon the height of the liquid column. So that we will discuss clearly in the next slides. Okay, if you see here, if you see here, so this is the one container which is having different shape and these three are different shapes. But if you measure the pressure at this point and measure the pressure at this point and measure the pressure at this point, all are at same height. So the pressure formula is P is equal to rho g h. That means irrespective of the shape, you will get same pressure at different points. So that means that static fluid pressure does not depend upon the shape, total mass or surface area. Here if you measure, the surface areas are different, shapes are different, and if you calculate the mass of each liquid will be different, but still you will get the same pressure. That means the pressure intensity depends on the only height of the fluid column. It is independent of the total mass or independent of the shape or independent of the area. If you see, these are also three different shapes, but still you will get same pressure if the height of the fluid is same. But here if you see, the volume of the fluid is very small here, but because of this height you will get more pressure at this point because it is depends upon the height of the fluid column. I hope you understand this concept. Again we will discuss here. If you see here in this, so this is the one container which is having 100 liters of liquid. In one tank we have 100 liters of liquid. In second tank, this is in another shape. So here also we have 100 liters of liquid. So at, for example, if it is this tank A and tank B, the volume in tank A, is, you can say 100 liters, and tank B also 100 liters. The shapes are different, the height of the water will be different, but the volume is same, right? But if you measure the pressure, at this point, at the bottom of the tank, I want to measure the pressure at this point. The formula is rho g h, right? For example, this height, I can say 1 meter. This height of the fluid is 2 meters. So now I will get twice the pressure in tank B than tank A. Even though the both tanks have the same volume 100 liters, but still the pressure at the tank B is more than the pressure at the tank A because it is independent of the mass of the fluid or volume of the fluid, you can say. And also if you see, there is a liquid jet at three different openings. If you see the pressure here, it is less. Why it is less here? Because the height of the liquid column is very small when compared to this or when compared to this. Here the height of the liquid column is more at the third jet, so you will get high intensity, more pressure. So the liquid jet, you will get a strong water jet and which travels more distance than the jet 1 and jet 2, right? So these, from all this we can say the pressure is only depends upon the height of the liquid column. It's not depend upon the mass or a shape or the area of the liquid column, liquid or fluid. Okay, I hope you understand this concept. Next, we will try to understand atmospheric, gauge or vacuum pressures. Okay. So first we will see the pressure and the fluid. Generally we will different two systems. In one system we will measure absolute, we will consider absolute zero as a reference, that is called absolute pressure. The pressure absolute zero or complete vacuum, if you consider as a reference, that is called absolute pressure. In other system we will take the atmospheric level as a reference, that is called atmospheric pressure. If you see the definitions, the absolute pressure is defined as the pressure which is measured with reference to absolute zero, with reference to absolute vacuum pressure, absolute vacuum pressure or absolute zero, that you can call as the absolute pressure. And if you measure the pressure with respect to atmospheric pressure as a datum. So normally the gauge pressure is measured with the help of pressure measuring instruments. So if you take atmospheric pressure as a reference line or a datum line, that pressure you can call as a atmospheric pressure. So that pressure you can call as a gauge pressure. So in the gauge pressure, the atmospheric pressure is taken as a reference. Again I will quickly summarize. There are two ways to measure the pressure. One is taking as an absolute vacuum as a reference, that is called as absolute pressure, or if you take atmospheric pressure as a reference, that you can call as a gauge pressure. Anyway, we will discuss in detail in the coming slides. Yeah, if you carefully observe this figure, so this is absolute zero. So this line is represent absolute vacuum or absolute zero. So for example, I am measuring the pressure at a point A. So I am taking reference as a absolute zero. I am taking reference as absolute zero and absolute vacuum. So that pressure you can call as a absolute pressure. Absolute pressure. So I am measuring the pressure at this point, but I am taking absolute zero as a reference. So if you measure the pressure by considering if you consider absolute zero as a reference, that you can call as absolute pressure, right? And in another way, so I am measuring the pressure at this point, same point A, but in this time I have considered the atmospheric pressure. This is the atmospheric pressure line. If I consider the atmospheric pressure line as a reference, this is called a gauge pressure. So again I will tell you, if you consider absolute zero or absolute vacuum as a reference, that pressure is called as absolute pressure. And if you consider as atmospheric pressure as a reference, that pressure you can call as a gauge pressure. The gauge pressure is measured with the help of some pressure measuring instruments. Now what is vacuum pressure? The pressure measured below the atmospheric pressure, that you can call as a vacuum pressure. So the pressure measured below the atmospheric pressure. So this is the vacuum pressure. So which is below the atmospheric pressure. The pressure measured below the atmospheric pressure you can call as a vacuum pressure. Now if you consider, for example, if you see the point B, so I am measuring the point B pressure with respect to absolute zero. So that's why this is called as a absolute pressure. So here absolute pressure as a reference. This is absolute pressure. If I measure this pressure with respect to atmospheric pressure, that you can call as a vacuum pressure, right? That you can call as a vacuum pressure. This is also comes under vacuum pressure. So from this we can say so here absolute pressure is okay. So here vacuum pressure is atmospheric pressure minus absolute pressure. If you want to find out the vacuum pressure, so this is the atmospheric pressure. This is the atmospheric pressure. If you minus the absolute pressure, you will get vacuum pressure, right? So vacuum pressure is okay. I will tell you in the next slide. Yeah. If you see here, the absolute pressure is gauge pressure plus atmospheric pressure. If you see here, the absolute pressure is, this is the absolute pressure. That means From here to here, this is the atmospheric pressure. Yeah, this is the atmospheric pressure, and if you add atmospheric pressure plus gauge pressure, you will get absolute pressure. You will get absolute pressure. Atmospheric pressure plus gauge pressure, you will get absolute pressure, right? So it is absolute pressure is P atmospheric pressure plus gauge pressure. What is the vacuum pressure? Atmospheric pressure minus absolute pressure. So you want to measure the vacuum pressure at this point. So here see, this is the absolute pressure, atmospheric pressure. If you subtract atmospheric pressure from the absolute pressure, this is the absolute pressure, right? So you will get this one. That is vacuum pressure. So vacuum pressure is nothing but atmospheric pressure minus absolute pressure. Okay. So don't get confused. There is a little bit confusion here, but don't get. So here the atmospheric pressure is also known as a barometric pressure, and which is expressed the atmospheric pressure, the barometric pressure. The value is 101.35 kilopascals. That is approximately equal to 1 bar. This is the way to measure the pressure. The units are atmospheric pressure. So the standard atmospheric pressure is 101.325 kilopascals, right? Which is equal to 760 mm of Hg. What this means? 760 mm of Hg. For example, that means, for example, if you take a container which is filled with mercury. Yeah, there is a vessel or container, whatever it is, which is filled with mercury. So the height of this mercury column is 760 mm. The height of this mercury column is 760 mm. So the pressure exacted by this 760 mercury column at the bottom, that is, if you measure the pressure, it is P is equal to rho G H. H is this one, rho is the density of the mercury, that is 13,600. So whatever the pressure you will get, that will be equal to the atmospheric pressure, that is approximately equal to 101.325 kilopascals. So in your problems, while solving the numerical problems, they will not provide you the atmospheric pressure in some cases. Then you have to assume 760 mm of mercury to calculate the atmospheric pressure, or directly you can take it as 101.325 or 1 bar. So again I will quickly revise. I thought there may be a little bit confusion. Simply I will tell you, if you want to calculate the, see, this is a you need to understand what is absolute pressure, gauge pressure and vacuum pressure. So what is the relationship? If you measure the pressure with respect to absolute zero, that is called absolute pressure, and if you measure the pressure with respect to atmospheric pressure, that is you can call as a gauge pressure. And if you measure the pressure below the atmospheric pressure, that is called as a vacuum pressure. So absolute pressure is nothing but atmospheric pressure plus gauge pressure. So absolute pressure is nothing but atmospheric pressure plus gauge pressure. Similarly, vacuum pressure is nothing but atmospheric pressure minus absolute pressure. This is the absolute pressure and this is the atmospheric pressure. If you want vacuum pressure, you have to subtract from the atmospheric pressure. So P absolute. So this you have to remember. Okay, not remember, actually you need to understand. Okay, this is the relation between gauge pressure, atmospheric pressure and vacuum pressure. Okay, I hope you understand this concept. Yeah, this is the same concept what we discussed so far. If you carefully observe this diagram, what is the total pressure here? Total pressure, which includes the atmospheric pressure, but if you want the gauge pressure, you have to subtract from the atmospheric pressure, right? See here, so for example, if I measure the pressure at this point, so how I measure? Rho G H. So this is the gauge pressure, right? But what is the total pressure, which includes the atmospheric pressure? Already atmospheric pressure is acting, so that I will not consider. I am considering that as a reference. That's why it is a gauge pressure, right? So if you want the gauge pressure, you have to subtract from the total pressure minus atmospheric pressure, then you will get the gauge pressure, right? So this we already discussed the pressure. The atmospheric pressure is 101.325 kilopascal, which is equal to 1 bar or 14.696 psi, pound per square inch. Pounds per square inch. This relationships also we already discussed. Right? Now, yeah, this normally we will do sometimes. If you pour the water in a cup of one glass and if you kept paper underneath, sometime if you rotate, the paper will not fall down, right? Sometime it will hold the water. So why it is happening? Because the atmospheric pressure, when the atmospheric pressure is more than the weight of the fluid, then the paper will hold the water, so it will not spill down, right? So it's happened because of the higher atmospheric pressure than the weight of the fluid. In that case, if you apply small push, so if you up the weight, if this weight exceeds the atmospheric pressure, so what will happen? The water will fall down immediately. So this is simple experiment, mostly we will used to do in our childhood. So this we already discussed, right? The total pressure, absolute pressure is nothing but atmospheric pressure plus gauge pressure. Okay. Now, this is a very important observation. If you see, we already discussed, right? This is the atmospheric pressure. The atmospheric pressure surrounded us. So that is 101.325 kilopascals. But what will happen if you go up? So if I go up, the atmospheric pressure will reduce. If I go up, the atmospheric pressure will reduce. See, at the mountain top here it is showing 31 kilopascals. At some point above the ground it is 0 kilopascals. Why the pressure will reduce if I go up? This is majorly because of the molecular spaces. At the atmosphere, the molecules are very closely packed. That's why they will exert high pressure. If you go up and go up and go up, the molecules are spare apart. So the distance between the molecules is very increases. See, the molecules are spare apart. So that's why that pressure will reduce. So for example, if you say, for example, this mountain is 1 kilometer above and this is 15 kilometers. So the pressure at 1 kilometer above the ground will be more than the pressure at 15 kilometer above the ground. So if you go up, the pressure intensity will reduce. This is majorly because of the molecular attraction. So the molecules are very closely packed at the near the surface, and the distance between the molecules will go on increasing if you go up. This is the reason the pressure will vary along with altitude, right? So if you go up, the pressure will reduce. At the mountain, you will feel less pressure when compared to the ground surface. Atmospheric pressure. I am talking about atmospheric pressure. This is because of molecular space. And if you see, for example, you are swimming at the top of the surface. So it will exert a pressure of 1 atmosphere. But if you go down, if you go deep, so the height of the liquid will acting on you, right? So if now I am 10 meters below this is the surface. Now I am 10 meters below the water. So what is the pressure acting on me? It is atmospheric pressure plus rho g h, right? This is 10 into 10 meters, right? This is the pressure will add, additional pressure, right? So if you go deep and go deep and go deep, for example 100 meter below it is 1 MPa, and if you go deep, it will be, the pressure keep on increasing. It's very difficult to bear that pressure. That's why we cannot go in deep to the sea, or we cannot go in deep to the you can say canal or whatever, right? If you go down, if you go deep into the water, so you will get more pressure. So the more pressure is applied on you. So it's very difficult to bear the pressure. We know that the water have very high intensity of pressure which can break, right, anything. So that's why we will not go in deep. So always we will try to be on the surface of the water. If you go deep, the pressure will be more. Okay. Now we will try to solve one numerical problem, then we will close this session. So now this is the problem, right? What are the gauge pressures? So you have to find out. First we will try to identify what is the data is required. So what are the gauge pressure and absolute pressure at a point 3 meter below the free surface of the liquid? Okay, that means there is a container. So he asks you to find out at a point 3 meter below the free surface of the liquid, okay, which is filled with liquid. Yeah. So you have to find out the pressure at this point, which is 3 meters below the free surface of the liquid. Free surface of the liquid. You have to find out the pressure at this point 3 meters below the free surface of the liquid. Okay. Next, density. What is the data is given? The density of the liquid. So we don't know what is the fluid there in that container. The density of the fluid is given as 1.53 into 10 to the power of 3 kg per meter cube. Okay. If the atmospheric pressure is equivalent to 750 mm of mercury. So now he said he given expression for atmospheric pressure, not given directly. He said in terms of equivalent to 750 mm of mercury. That means okay, we'll do. So P atmospheric pressure will be equal to 750 mm of mercury. Okay, I will tell you how to utilize this. And also another data is given as specific gravity. Specific gravity, okay, I think there is a one term missing. The specific gravity of mercury, yeah, the specific gravity of the mercury is 13.6. So S of mercury is, specific gravity of the mercury is 13.6. Next, and density of water. So density of the water is 1000 kg per meter cube. And you have to calculate atmospheric pressure, absolute pressure and gauge pressure. You have to calculate gauge pressure and P atmospheric pressure. Okay. So this is the data is given. First we will try to find out the atmospheric pressure. Okay, sorry, we have to find out absolute pressure. Okay, sorry. You have to find out absolute pressure. Okay. Now, first we will try to find out the atmospheric pressure. So atmospheric pressure is equal to 750 mm of mercury, right? So now, yeah, I will go that side. Okay. So P atmosphere will be equal to, what is the formula for pressure? The pressure is rho g h. What is the rho value here? So density of the water we will take 1000, oh sorry, mercury, right? What is the H value? H value in terms of 750 mm of mercury. So rho value we have to consider as a density of mercury. So we don't know the density of the mercury, but in the problem it has given specific gravity of the mercury. So we know that specific gravity is equal to density of the fluid by density of the standard fluid. So we know this is 13.6. Density of the fluid, that we need to calculate. Density of the fluid, density of the standard fluid is 1000 kg per meter cube. Density of the standard fluid is water. We already solved this kind of problems, right? So now finally you will get density of the fluid as 13,600 kg per meter cube. Now you know the density of the fluid. You know G, that you can assume 9.81, and H value is already given, 750 mm of mercury. So you can solve this problem. Okay, shall we do this? I will rub this part. Okay, now we know the density, right? I will rub this part. Okay. Now atmospheric pressure is equal to rho GH, that it means 13,600 into 13,600 into 9.81 into H value. What is the H value? 750 mm. That means 0.75 meters. Right? Because this is kg per meter cube, right? So this is in meter per second square. So every other units are meters. So this will be in meters. So if you calculate, you will get 1 lakh. I think you will get 1,62,000. 1,62,000 Newton per meter square. This is the atmospheric pressure. Okay, now we know atmospheric pressure, right? We need to calculate the gauge pressure and absolute pressure. What is the gauge pressure? So gauge pressure will be equal to P atmospheric pressure plus, so the pressure measured with respect to atmospheric pressure, as per atmospheric pressure plus measured pressure, right? That is rho GH. This will be the gauge pressure. Okay. So what is the rho GH? That we will measure, right? Okay. We'll write. Oh, sorry. This is 1,62,000. Okay. Now we will try to measure the pressure. So for the pressure measurement, he has given it is 3 meters below the free surface of the liquid. So height of the liquid column is given. So fluid density is given. So that means pressure is equal to rho GH. So rho GH. Right? What is rho value here? Rho is 1000. G value is 9.81 and H value is 3 meters. So that will be how much? Rho GH, that means 3 into 3000 into 9.81. This will be rho GH. Oh, sorry, rho value. Okay, it's not water. Oh, sorry. Density of the fluid is given 1.53 into 10 power of minus 3, right? 1.53 into 10 to the power of minus 3. So then you will get how much? 45,028 Newton per meter square. So this is the gauge pressure, the pressure measured with reference to atmospheric pressure. So here there actually atmospheric pressure is acting, but we measure this pressure with reference to this atmospheric pressure. The atmospheric pressure here we consider as a 0, right? This is the gauge pressure, that means measured pressure. Okay, then what is absolute pressure? Absolute pressure is nothing but, in the earlier diagram we have drawn, right? For this is the atmospheric pressure, this is absolute 0. If you measure the pressure with reference to absolute 0, that means atmospheric pressure plus gauge pressure. Pressure measured with respect to gauge pressure, right? This is the gauge pressure. If you want absolute pressure, it is this point. That means atmospheric pressure plus gauge pressure. If you add this atmospheric pressure to this gauge pressure, P gauge, so you will get the total pressure. That I will calculate again. We will rub this part. Okay. Again I will tell you, see, this is a absolute 0. This is absolute 0. So this is the atmospheric pressure. Okay. So what is the gauge pressure? The pressure measured with respect to atmosphere, right? This is the gauge pressure. So here we have measured the pressure at this point with respect to gauge. That is means absolute pressure. So that is the gauge pressure with respect to atmospheric pressure. What is the absolute pressure? Atmospheric pressure plus gauge pressure. You will get absolute pressure. Atmospheric pressure plus gauge pressure, you will get the absolute pressure. So P absolute will be equal to P gauge plus P atmospheric. So P gauge how much? P gauge pressure is, we got around 45,028 Newton per meter square plus atmospheric pressure is 1,62,000 Newton per meter square. So overall you will get 45,000, right? 1,45,090. 90 Newton per meter square. So this is the absolute pressure. So I hope you understand this concept. So thing is, you have to remember this relationship. This is very crucial for this problem. So to solve any fluid mechanics problem, first you try to understand what is the data is given, what is the variables you need to find out. You have to identify known and unknown variables. So then only, and also you need to know the relationship between the known and unknown values. Then only you can solve any fluid mechanics problem. So we need to know these relationships. Here he asks you to calculate the absolute pressure. That means we measure the pressure with respect to absolute zero. But here we have, he has given the atmospheric pressure and he has given the variables to calculate the gauge pressure. So if you add this atmospheric pressure plus gauge pressure, you will get absolute pressure, right? Yeah, I hope you understand today's lectures. So thank you for your attention, and for any further references you can refer Barke Bansal textbook. In next class we will discuss about the Pascal law, how to what is Pascal law, and we will try to derive the expression for Pascal law, and we will try to solve some numerical problems related to Pascal law. Thank you for your attention. Thank you.